Here we have a lesson on circuit symbol diagrams. For your reference, these are mostly all taken out of your textbook. These are the pages where you can find them. And so we're going to go through and we're going to talk about different parts or different things that you might see in a circuit and basically the symbols that we use when we're drawing circuit diagrams. So first is an electrochemical cell. And this, as the name suggests, converts chemical energy into electricity. Okay, the long bar, so when we actually draw the symbol for what this looks like, we come to something that looks like this. Okay, so this is the symbol. We've got a short bar, we've got a long bar. The long bar represents the positive terminal, and the short bar represents the negative terminal. Okay, so those are two things that we want to remember. And we know that because electrons are negative, they flow away from a negative towards a positive. Okay, so they flow away from negative towards positive. There's all different types of electrochemical cells. There's AA, AAA, C, and D, and those represent the different sizes. But this is basically what one of these things looks like, and you can very often tell the positive electrode has the little bump on it, and the negative electrode is the flat side. Okay, so that's the electrochemical cell. Now, typically, a battery then would be a combination of many individual electrochemical cells. So in this case, we've got three. So the way that we would draw this is three electrochemical cells all together. And we would always want to mark the negative side of the battery and the positive side of the battery. And so we can see then in this diagram that this right here would represent just one of these objects, of these electrochemical cells. So that would be one, this would be another, and there would be a third. Okay, so that's three of those together. And when we connect them end to end, we're always going to connect them in a straight line. And we call that series, as we've talked about. The total voltage is the addition of the individual voltages. So very often when we have one of these little electrochemical cells, we'll notice that the individual voltage is about 1.5. Okay, and so then if I connect these in a straight line, I've got 1.5 here, I've got 1.5 here, and I've got 1.5 here. So the given voltage, the total voltage then, would be, as you may have guessed, 1.5 plus 1.5 plus 1.5 for a total of 4.5 volts. Okay, and that's how we do that. So many electrochemical cells together is a battery. One individually, we just call it an electrochemical cell. All right, so a light, something that is a light, a little lamp, we would do like this. Okay, so it's a little curly Q and then a circle around the whole thing, and you can see that kind of looks a little bit like a light bulb. These are just schematic diagrams, so they don't have to look perfect. This is a load that converts electricity into, of course, light energy. And so an example of this would be a light bulb. Or an LED, etc. Okay, so these are all examples. A motor has a very simple diagram. It's just a circle with an M in the middle of it. And this is a load that converts electricity into movement. Okay, and so an example of where we might see a motor would be in your computers. There are cooling fans, and those cooling fans, in order to make the fan move, would have a motor. All right, so a resistor is another kind of load that we can have in a circuit. And a resistor is like a zigzag line, okay? So this is the circuit diagram for a resistor. And this is a device that impedes or resists the flow of electrons through a circuit. We're going to talk a lot more about resistors and resistance in the coming days, but the unit of measurement that we use is something that's called the ohm, okay? And it has a symbol that looks like this, okay? And we're going to talk much more about resistors and when they might be useful in a couple of days. So a switch is a control device, and we can see that down here. These are all the different control devices we're going to talk about. And a switch, if we want to show this in the open position, would look like this. Okay, and this is something that we call a control device. And the reason that we call it that is because we use these control devices to control the flow of current. All right, another control device is a fuse, and the circuit symbol for a fuse is a rectangle with a broken line in the middle of it. And so fuses, especially if you have a home that does not have a circuit breaker but has a fuse box, fuses have a thin wire in the middle that you can see here. And if the current gets too high, the thin wire will melt and it will break the circuit, and it means everything will shut down. So it really is a safety device. So it's a control device, and it contains a wire that melts if the current gets too high. So if there's no fuse and the current gets too high, fire could occur due to overheating, because when current runs through a wire, that wire will get hot because of resistance. We're going to talk a lot more about that, but a fuse is a safety control device, and it'll melt. And of course, as soon as this wire melts in the middle, it's an open circuit, and it's kind of like having an open switch, and current can't flow anymore. All right, so an ammeter is one of the last things on our list down here, and an ammeter has a symbol similar to a motor. It's got an A in the middle of it. An ammeter measures the number of electrons flowing past a point in the circuit, and this is measured in amps. So it actually measures electrons, but really indirectly, because electrons are too small, it's not going to tell us the exact number of electrons. It really measures the amount of charge that flows past a point in the circuit. We measure that in amps, and it's related to the current, okay? Or the flow rate of electrons. So an ammeter, this is what's important right here that you remember. An ammeter, which measures current in amps, this is measuring the current, and we connect this in series in a circuit. A voltmeter is something a little bit different. Again, you could probably guess what the symbol for a voltmeter might look like. It's going to be a V, okay? And this measures the amount of potential, right? So the amount of energy that each electron is given in volts as it travels between 2 points. And this is connected in parallel. Okay, so we're going to talk about those two things in a bit, what series and what parallel all means, but these are your circuit symbols.